Now we will see question number 1. Prove that 2 upon factorial 1 plus 4 upon factorial 3 plus 6 upon factorial 5 plus 8 upon factorial 7 and so on up to infinity is equal to E. Now here we know that E is defined as E is equal to 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3 and so on up to infinity. Now if I club the numbers like this, that first and 2 are taken, third and fourth are taken, and likewise, then I obtain while solving that first bracket will be 1 plus 1 upon 1 plus second bracket will be 1 upon 2 plus 1 upon 6 and likewise to infinity, because factorial 3 is 3 into 2 which is 6. When solving the brackets I obtain, this will be 1 as denominator. In numerator I will be having 1 plus 1 plus second bracket LCM will be 6. Here I will be obtaining 6 divided by 2 is 3. So 3 will come here plus 6 divided by 6 is 1. So 1 will come here plus and so on up to infinity. So this will be 2 upon 1 plus 4 upon 6 plus and so on up to infinity. Now 1 can be written as factorial 1. This 6 can be written as factorial 3. So this will be equal to 2 upon factorial 1 plus 4 upon factorial 3 plus and so on up to infinity. And likewise the other terms can also be computed. So this is what we are required to prove. So hence 2 upon factorial 1 plus 4 upon factorial 3 plus 6 upon factorial 5 plus 8 upon factorial 7 and so on up to infinity is equal to E. Hence proved. Question number 2. Prove that 1 plus 3 upon factorial 2 plus 5 upon factorial 4 plus 7 upon factorial 6 plus and so on up to infinity is equal to E. We know that definition of E is E is equal to 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3 plus 1 upon factorial 4 plus 1 upon factorial 5 and so on up to infinity. This is by the definition of E. Now if I club the numbers in this fashion, that E is equal to 1 plus 1 upon factorial 1 plus 1 upon factorial 2. These two numbers I have taken together in one bracket plus 1 upon factorial 3 plus 1 upon factorial 4. These two I have taken together plus 1 upon factorial 5 plus 1 upon factorial 6. This I have taken together plus so on up to infinity. Then I know that factorial 2 is equal to 2, factorial 3 is equal to 6, factorial 4 is equal to 24, factorial 5 is equal to 120, factorial 6 is equal to 720, and likewise then I can write that E is equal to 1 plus 1 upon 1 plus 1 upon 2 plus 1 upon 6 plus 1 upon 24 plus 1 upon 120 plus 1 upon 720 plus and so on up to infinity. Solving this gives us 1 plus 2 can be taken here in the first bracket as LCM. In numerator, we will be getting 2 plus 1. Plus again, solving this bracket, 24 will be LCM. Here I will be obtaining 4 plus 1 plus here LCM will be 720. I will be obtaining 6 plus 1 in the numerator plus so on up to infinity. Solving this gives us 1 plus 3 upon 2 plus 5 upon 24 plus 7 upon 720 plus and so on up to infinity. Now again I see that this 2 can be written as factorial 2. This 24 can be written as factorial 4. 720 can be written as factorial 6. So I can write this is equal to 1 plus 3 upon factorial 2 plus 5 upon factorial 4 plus 7 upon factorial 6 plus so on up to infinity. And this is what we are required to prove, that 1 plus 3 upon factorial 2 plus 5 upon factorial 4 plus 7 upon factorial 6 is equal to E. So hence proved.